Otto cycle. The Otto cycle introduced by An Otto in 1876. Two graphs are plotted between PV and TS diagram for the Otto cycle, in which PV diagram two, three, four. One to two is reverse adiabatic compression. 1 to 2 is adiabatic compression. Whenever piston goes from bottom dead centers to top dead center. Reverse adiabatic compression from 1 to 2. The volume decreases in 1 to 2. In process 2 to 3 is heat supply. Heat supply to the petrol in the cylinder. And process 3 to 4 is reversible adiabatic expansion. And process 4 to 1 is heat rejection. So it is the PV diagram for the Otto cycle. That is the pressure, volume, and this is clearance volume. This is clearance volume, and from this to this it is swept volume. And temperature P2, P3, pressure P4, pressure P1. It is the PV diagram and TS diagram. This is 1, 2, 3, and 4. 1, 2, 3, and 4. Temperature versus entropy. Temperature, entropy. So in which in a Otto cycle, the heat is supplied in the process. In the process 3 to 2, so 2 to 3, it is supply. When the heat is supply, QS heat supply is equivalent to CV specific volume T3 minus T2 in 2 to 3 process heat supply CV T3 minus T2 and heat rejection process heat QR heat rejection is equivalent to CV in the process 4 to 1 T4 minus T4, that is heat rejection and heat supply. The work is done. How we calculate the work? Work is equivalent to QS minus QR. So in which QS, see that QS is equivalent to CV T3 minus T2 minus CV T4 minus T1. This is our work done. Now efficiency, and efficiency of Otto cycle is equivalent to work done over heat supply, that is equivalent to our work done CV T3 minus T2 minus CV T4 minus T1 divided by heat supply CV T3 minus T2 is heat supply, that is equal to 1 minus T4 minus T1 divided by T3 minus T2. And this is our efficiency of an Otto cycle. This is the efficiency of an Otto cycle. Clear? Yeah. That is efficiency of an Otto cycle 1 minus T4 minus T1 divided by T3 minus T2. And applying it's moving and applying isentropic law to the point 3 and 4 and 4 1 and 2. Yeah. Okay. So that is equivalent to T4 is equivalent to T3 V3 divided by V4 to gamma minus 1. Exact. Applying isothermal law, T4 is equivalent to T3 V3 V4 and gamma minus 1, and T3 and V3 is equivalent to V2 V1 gamma minus 1, because V3 is equivalent to V2, V3 is equivalent to V2, and V4 is equivalent to V1. You see that? V3 is equivalent to V2. V3 is V3 and this is V2. V2 is equivalent to V3 and V1 is equivalent to V4. It is equal to V2 and V3 is equal to V4. So after that, T1 is equivalent to T2 V2 by V1 gamma minus 1. So put this value T4, T1 in the equation, in the efficiency of an Otto cycle. In the equation 1. What in equation 1? Equation 1. So you see that Na efficiency 1 minus T3 clear you, and is equal to efficiency of water cycle is efficiency of water cycle, and 1 minus T4 minus T1, T3 minus T2. So put this value in this equation. So y that is equivalent to 1 T4 T3 V3 T3 V2 V1 gamma minus 1, and what is T1? What is T1 is T2 minus T2 V2 by V1 gamma minus 1 divided by T3 by T2. So that is equal to 1. Take it common. V2 by V1 gamma minus 1, V2 by V1 gamma minus 1. Take it common, this value. So when we take it common, V2 by V1 gamma minus 1, left is that T3 minus T2 over T3 minus T2, that is cuts. So 1 minus V2 by V1 equal to gamma minus 1. V2 by V1 is gamma minus 1, and you see that V1 over V2, that is equal to Vs plus Vc by Vc. And how is that? A graph is about that. This a PV diagram, pressure, volume, and point 1, 2, 3, 4, and this is Vc, and this is Vs, so volume, swept volume, minus Cc. So it is V1, this is V1, sorry, here, V1 is equivalent to, so V1 is equivalent to Vs plus Vc. You clearly see that V1 is equivalent to Vs plus Vc, and V2 is equivalent to V2 over clearance volume Vc is equivalent to V2, and this is equivalent to, so V1 is equal to V2, that is equivalent to Rc, that is our compression ratio. So efficiency of the Otto cycle is also calculated by this formula, and the compression ratio is also calculated by this formula. Rc is our compression ratio, and this is the efficiency and compression ratio for the Otto cycle.